Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular video is AQA New Practice Set 1 Foundation Tier Paper 1 Non-Calculator. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Question 1. What is 1/5 as a percentage? Now, a percentage is just a fraction over 100. So if we can take our fraction and rewrite it as a fraction over 100, then the number on the top is going to be the percentage. So how many times does 5 fit into 100? Well, if I multiply the bottom by 20, 5 times 20 is 100, but I'll then need to multiply the top by 20 as well, won't I? So 1/5 is the same thing as 20 1/100ths, and 20 1/100ths is the same thing as 20%. So it's that one there. Part B says, what is 0.9 as a percentage? 0.9, again, can I write that as a fraction? So after the decimal point, you've got tenths, haven't you? So 0.9 is the same thing as 9/10. And again, rewriting that as a fraction over 100, I can do that by multiplying top and bottom by 10. So 10 times 10 is 100. 9 times 10 is 90. So 90 1/100ths is the same thing as 90%. So that's my answer there. Question 2. There are 20 students, 12 are boys. What fraction are boys? Circle your answer. Okay, so there are 20 students and 12 are boys. So 12 20ths then are boys. Okay, now you'll notice that none of my fractions have got 20 as a denominator as our choices, but 12 20ths does cancel down, doesn't it? If you think about it, 12 has factors 1, 3, 4, 6 and 12, and 20 has factors 1, 2, 4, 5, 10 and 20. So we can divide top and bottom by 4. That's the largest common factor. That will give me 3/5 then as my fraction, so that's the answer there. Question 3. Simplify 7x plus 5 minus 8 minus 3x. Okay, so basically we just need to collect like terms here. So I've got 7x, which is a like to 3x, and I've got 5, which is a like to 8. So if I highlight them like that, hopefully it's a bit clearer to see then that 7x subtract 3x is 4x. They're the yellow things combined together. And 5 subtract 8 is minus 3. So if I combine the green bits together, I'm going to get -3. And altogether that's 4x minus 3 then, isn't it? So that is my answer there. Question 4. The table shows how 25 students travel to school. So you see that 9 walk, 8 go on the bus, 7 come in by car, and 1 comes in by taxi. We need to draw a bar chart to show this information. Okay, so we've just got some square paper. There's no axes drawn yet, so we need to draw those on. Now, just checking through here, you can see that the highest number there that we need to go up to is 9. And counting squares up the left-hand side here, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares. So basically I can use each square as 1 then, can't I? So there's 0 down there. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll go up to 10 even though I know it's only going up to 9. Okay, so I've done my scale at the left hand side. Now I need to have a bar for walk, bus, car and taxi. Now this is discrete data. So I need to space my bars out really. Shouldn't really have them bumping up against each other. So I'm going to have my walk bar here. And then I'm going to have a space of 1 unit. And then I'm going to have bus here. So this will be walk, bus, what's the next one? Car and taxi. So another space of 1 and then car. And then a space of 1 and then taxi. Okay. So then let's just label those axes. So this is going to be frequency up the side. And along the bottom, this is type of transport, isn't it? So just labeling my axes, come up with a suitable title for those. Right, now finally I just need to draw the bars at the right height. So walk is of a height 9. So you can see I've drawn a rectangle of the right height now. So bus had a height of 8. Car was 7. And finally, taxi was 1. Okay, so I'm reasonably happy with my bar chart there. Like I say, the most common mistake with these sort of things is people pushing their bars up against each other, not having this space in the middle. You need to have a space between your bars when you've got discrete data. Okay. Also, don't forget that you need to label axes again. That is something that people might forget. Question 5. Here are 3 events for an ordinary fair dice. A is roll an odd number, B is roll a number greater than 6, and C is roll an even number less than 3. It says draw and labelled arrows to show the probabilities of event B and C on the probability scale. So they've already done A for us here. So you can see A roll an odd number is there in the middle. Okay. So let's have a look at the scale here. It goes from 0 to 1, and there are 1, 2, 3, 4, 5, 6 divisions in between. So this is going up in 6, isn't it? So that's like 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6, or 1. Okay. Now probability is defined to be successful outcomes divided by total outcomes. Okay, now when you roll a dice, there are 6 possible things that can happen. So all of these probabilities are going to be out of 6. Now rolling an odd number, there are 3 possible choices. You could get a 1, a 3, or a 5. So that gives it a probability of success of 3 out of 6, which is why A is in the middle there. 3 out of 6 is the same thing as 1/2, it's in the middle. B, roll a number greater than 6. Well, how many numbers greater than 6 are there? Well, the numbers go from 1 to 6, so there are 0 answers that are greater than 6. That's going to be 0 out of 6 then, isn't it? So B is going to be, well, let's do it neatly. Let's get a ruler out. Okay, so we'll draw our arrow there. For B, no chance of getting a number greater than 6. So that then is B. And then C, roll an even number less than 3. So what even numbers are there less than 3? Well, the numbers less than 3 are 1 and 2, and only one of those is even. And that's the answer 2, isn't it? So you've just got 2, which gives you 1 out of 6 possibilities. So then my C event is going to be here. Let's just draw that one. So this is going to be C here. Okay. Question 6. Work out 23.7 minus 2.5 times 8. Okay, now this is a non-calculated paper, so I can't just shove it into a calculator and press equals. So I'm going to have to work this out. First thing to remember though is this is BIDMAS, order of operations. Now BIDMAS says that multiplication comes before subtraction, so that means we need to do this part of the calculation first. So we're going to have to multiply 2.5 by 8 first, and then subtract the answer from 23.7. So what is 2.5 times 8? Okay, well, timesing by 8 is doubling, doubling, and doubling again, isn't it? So if you double it, you're timesing it by 2. Double it again, you're timesing it by 4. And if you double it again, you're timesing it by 8. So 2.5 doubled is 5. Doubled again is 10. And doubled again is 20. So 2.5 times 8 is 20. And 23.7 subtract 20 then. Well, that's really easy. That's just 3.7. So that's my answer. 3.7. Question 7. Write these numbers in order starting with the smallest. And we've got 4 different decimal numbers here. These can confuse people sometimes because they've got different numbers of decimal places. Sometimes people find it easier if you just pad it out with the extra zeros. So they will have the same number of digits. Usually makes people more able to read these correctly. So having a look at our numbers, I think 2000, now you can read them like thousands, 2030, 2300, 2303, 2330. So now I can easily see that's going to be my smallest. That one's going to come first. Then my next biggest one is going to be that one. My third biggest is that one there, and my biggest one is that one there. So that's the order that I'm going to write them down in. So answer is 2.03. Don't have to add the extra padding now. 2.3, 2.303, and 2.33, like that. Question 8. There are 25 counters in a bag. 12 are red, 5 are green, and the rest are white. A counter is chosen at random. Work out the probability that it is white. Okay, this is the second probability question, and we've already talked about probability in this paper, and the fact that it's equal to successful outcomes divided by total outcomes. So how many different outcomes have we got? Well, there are 25 bags, so there are 25 counters in the bag. So the total number of outcomes that are possible are 25. Now we want to know the probability that it's white, and we know that 12 are red and 5 are green and the rest are white. So how many white ones is that altogether then? 25 subtract 12 subtract 5. 25 subtract 12 is 13, subtract 5 is 8. So there's going to be 8 white counters. So there are 8 successful outcomes out of a total of 25. 8/25. Question 9. 110 students go on a school trip. Each student needs a bottle of water. Now, a pack of 6 here. How many of these packs are needed? So how many packs of 6 am I going to need to water 110 students? In other words, I need to divide 110 by 6, or how many 6s go into 110. Okay, so doing bus shelter division or short division, 6 goes into 1, doesn't go. 6 goes into 11 once, remainder 5. 6 goes into 50, how many times? Well, I know that 8 6s are 48, so it goes in 8 times, remainder 2. Okay, I'm just going to write that down as a remainder for now. So it goes in 18 times remainder 2. Now, I can't have a remainder here. I can only buy in multiples of 6. And if I buy 18 packs, it's not going to be quite enough. I'm going to have 2 students who don't get any water. So actually, I'm going to need to buy one more pack, aren't I? I'm going to have to buy 19 packs. So how many of these packs are needed? I need 19 packs. Question 10. AB is a straight line. Work out the size of angle X. Now notice it says not drawn accurately and it says work out, which means you can't just use your protractor and measure X. It's not going to give you the right answer. You can use the fact though that angles on a straight line add up to 180 degrees. So these three angles, 27 plus X plus 41, should add up to 180. Okay, so add in the 27 and the 41 together. That tells me that X plus, what's it, 41 and 27 is 68. X plus 68 is 180. And then taking 68 away from both sides should tell me that X is equal to 180. Subtract 68 is 112, isn't it? So X then is 112 degrees. 112. Question 11. Here is a centimeter grid. It's got some axes on it. A is the point 3,5, B is the point 0, -3, and C is the point -5, 2. What type of triangle is ABC? Well, in order to work that out, we're going to have to plot those points, aren't we? So 3, 5, that means that, well, we always get coordinates in the form x, y, so it's along and up, along the corridor and up the stairs, isn't it? So A at 3, 5 means start at the origin, go 3 along and 5 up. Should give me a point here. That's the point A. Okay, at 3, 5. So B is at 0, -3. So along 0 and up -3. It's actually down, isn't it? So B is going to be there. There's B. And then finally C is at -5, 2. So along -5, which means go left -5 and up 2. It's across there. Okay, so what sort of triangle is this? Well, let's draw it and see if it gives us a bit of a clearer picture. So, joining those points up. C to A. And then down there. Okay. Well, doesn't look like a right angle triangle. Could be an isosceles triangle. Looks a bit like an isosceles triangle. It looks like that length there is the same length as that one. How can we check? Well, we could just double check the distance in the direction of X and Y between those 2 points. So if you think about the distance from B to A, it's 3 units along and how many units up? That's 1, 2, 3, 4, 5, 6, 7, 8 units up, isn't it? 3 along and 8 up from there. And from C to A, it is a 3 units up. And along here, how many units is that? Counting that, 1, 2, 3, 4, 5, 6, 7. That's also 8. So I could use Pythagoras theorem to work out the actual lengths of those sides, but actually I don't need to. I just want to see if they're the same length, and I'm quite certain from looking at the fact that they have they're the same hypotenuse of a right angle triangle, that they must be the same length. So it's an isosceles triangle. So it's an isosceles triangle. Not the easiest word in the world to spell correctly. Question 12a. Circle the value of 2 to the power of 4. Okay, well 2 to the power of 4 is 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, it's that one there. Circle the value of 5 cubed. 5 cubed is 5 times 5 times 5. Again, 5 times 5 is 25, and 25 times 5 is 125. It's a good idea to know your cubes for the first 5 or 6 cube numbers. Comes in quite handy in the exam. Finally, circle the value of the root of 196. Similarly, knowing your square numbers is handy, because if you do, then you'll know immediately what the answer to this one is. It's 14. If you're not sure, you could just multiply them out, couldn't you, until you found the right one. Question 13, solve 4x minus 5 is equal to 17. So this is an equation. We're asked to solve it, which means to find the value of x. Okay, now when you've got an equation, you want to be doing the same things to both sides to try and simplify it down and isolate x. So I'm going to start off by adding 5 to both sides. If I add 5 to both sides, I'm not going to change the equilibrium. It's still going to stay balanced. But 4x minus 5 added 5 is just going to leave me with 4x. And on the right hand side, 17 add 5 is going to give me 22. Right, next, divide both sides by the coefficient of x. 4x divided by 4 is going to give me x, and 22 divided by 4, well, 20 divided by 4 is 5, isn't it? So it's 5 2/4, or 5 1/2. So 5 1/2, or 0.5 if you're more comfortable. Question 14. John has 78p, Nat has £3.52. Nat gives John some money so that they both have the same amount. How much does Nat give John? Oh, okay. Well, I think if we want to know what the same amount is, if we add both numbers together and then divide it by 2, we'll find out how much they have each, and then we can work out how much Nat must have given him. Okay, so let's do that first. Let's add £3.52 and 78p. So £3.52 and 78p added together. 2 and 8 is 0, carry 1. 5, 6 and 7 gives me 13, carry 1, and 4 and 1 makes, 3 and 1 makes 4. So it's £4.30. So £4.30 is their combined amount. Now if I divide that by 2, then halving, so half of £4.30 is going to be £2.15, and isn't it? So they're both going to end up with £2.15. Okay, so how much would have Nat given John so they both end up at £2.15? Well, he started off with 78p, so if I can work out the difference between 78 and £2.15, I'll know how much Nat gave. So now I've got to do a subtraction. So £2.15 subtract 78 pence. What's that then? 5 subtract 8 I can't do, so I'm going to borrow 1. 15 subtract 8 is 7. 0 subtract 7 I can't do, so I'm going to borrow 1 from there. So 10 subtract 7 is 3. And 1 subtract 0 is 1. So £1.37 is the difference between 78 pence and £2.15. So that must be the amount that Nat gave to John, £1.37. Question 15. A cinema has 37 rows of seats, 23 seats in each row. Adult tickets are £8 each, child tickets are £6 each. The cinema has sold tickets for every seat. The manager estimates that £6,400 was raised from these tickets. 200 child tickets were sold. Check whether the manager's estimate was close to the exact amount of money raised. Okay, well, got quite a lot of work to do here to work this out, haven't we? So where to start? Why don't we start off with working out how many seats there were altogether. So total number of seats. Now that's going to be 37 times 23. Okay, how do you do your multiplication? Maybe do column multiplication. maybe you use the grid method. I tend to recommend students use Napier's bones. So I'm going to quickly do that. So a little grid like that with diagonal lines drawn in. So 37 along the top, 23 down the side. 3 2s are 6, 7 2s are 14, 3 3s are 9, 7 3s are 21, and then with Napier's bones you add up along the diagonal, don't you? You seen this method before? So that's 1, 4, 2, and 9 add up to 15. So just carry 1 into the next diagonal. 1, 6, and that carried 1 adds up to 8, and that's 0. So once you've gone round like that, then your answer is here. So that equals to 851. So there are 851 seats altogether. Okay? So we've dealt with the number of rows and the number of seats over there, and that gave us 851. Okay, where to go next? So we've got 851 seats all together, and we know that 200 child tickets were sold. Okay, so from that we can work out the number of adult tickets and child tickets that were sold altogether. So we know that there are 200 child tickets sold, so adult tickets is going to be the total number of seats less the number of child tickets sold, which was 200. So that is 651. Okay, so we got adult tickets 651 and child tickets 200. Okay, so we know that adult tickets were £8 each, and we know that child tickets were £6 each. So we can work out the amount of money coming in now then. So total income is going to be our 651 adult tickets times an adult price of £8 plus 200 child tickets at £6. Okay, well, part of that is easy to do. 200 times 6 I know is 1200, so I can just write that one in. 651 times 8, it's not so easy to do in my head. I'm just going to do that as a separate calculation. Again, I can use Napier's bones method. So this is a 6 times 1, sorry, 3 digit by 1 digit grid. So 651 times 8. So 6 8s are, what, 48? 5 8s are 40. 1 8 is 8. And then adding up along the diagonals, that's 8, 0, 12, carry 1, 5. So my answer is 5208. So that's 5208 for the adult tickets, plus £1,200 for the child tickets. Adding those two numbers together, that is 6408, isn't it? £6,408. Okay. Right, so you remember the question was wasn't how much did we make, it was to check the estimate of the manager, and that the manager estimated it was £6,400. Now if we worked out it's £6,408, so looks like the manager was pretty much spot on, wasn't he? So I'm just going to write down the manager's estimate was accurate. Question 16. Here is a map of France, and we can see we've got several cities marked on the map, and we've got a scale down here. It says 1 centimeters represents 80 kilometers. Okay, what's the question ask? Over the page. What is the 3-figure bearing of Lyon from Bordeaux? The 3-figure bearing of Lyon from Bordeaux. So we're going to start in Bordeaux and we want to go to Lyon. Okay, right, so you'll notice at the top here we've got a direction line for north, and 3-figure bearings are always measured clockwise from north. So let's just get my ruler out. So straight up in the direction of that north line, look, that's north. So if I want to measure a bearing, I should really start by putting a north line on the point where I want to measure my bearing from. So I want to go directly north from Bordeaux. So drawing an up arrow from there. Okay, so that's my north line. And from Bordeaux, I want to go in this direction, don't I? Oop. Now, so using a protractor, what you want to do is you want to measure that angle in there. Okay, can't really show a protractor so well in this particular application, but if you plonk your protractor on and measure it, you should find that you get an angle of 84 degrees in there, 84 degrees, and then so to write that down as a bearing, 84 degrees has only got 2 digits. Okay, we haven't got 84. We've got 85 or 95 or 175 or 05. Okay, so I think that perhaps I was just a little bit out of my measurement. I'm going to say it's that one there, 0.85. It says work out the actual straight line distance from Paris to Marseille. Work out the actual straight line distance from Paris to Marseille. So Paris is up there in the north, look, and Marseille is down in the south. So let's join them up with a straight line. Now with your ruler, you're just then going to measure that carefully then. Count the number of centimeters is between Paris and Marseille. Now again, because I'm using an emulated ruler here, I'm not going to be able to accurately measure it to show you, but if I did get a ruler out, I think it is around about 8.2 centimeters. Now if you're working from a practice paper from your school because they printed it out for you, sometimes these things don't get reproduced correctly at the right size, so you might find that yours is slightly bigger or slightly smaller. Don't worry too much about that. It's just one of those things that happens when schools give their students practice papers. What you just need to make sure you do is you take whatever measurement you've got there and you multiply it by the length to get the you multiply it by the scale factor in order to get the correct distance. So the scale factor is 1 centimeter represents 80 kilometers, and I've got 8.2 centimeters. Each one of those centimeters is 80 kilometers. I'm going to have to multiply these two things together. Okay, so again, using Napier's Bones grid, I'll do my 8.2 times 80. 8 8s are 64, 2 8s are 16, 8 zeros, well, 0 and 0. What's that then? Adding up along the diagonals, that's 0, 6, 5, 6. So reading around my answer, around the edge here, I've got the digit 6560. Now remember I had one number behind the decimal point there, so I'm also going to have one down here that's behind the decimal point. So my answer is 656.0 or 656 kilometers. So what is the actual distance? It's 656 kilometers. Again, if you're working on a reproduced practice paper that's been photocopied by your school, it might be that it got stretched or squished a little bit. So your answer might be smaller or bigger than that. Don't worry about too much. As long as you multiplied it correctly by 80, I'm sure you've got the answer correct. Question 17. Here is some information about a group of children. I've got boys and girls, left-handed, right-handed. So this is what we call a two-way table. I've got 3 left-handed boys, 12 right-handed boys, 3 left-handed girls, and 20 right-handed girls. Write down the number of left-handed girls to right-handed girls as a ratio. Okay, give your answer in its simplest form. Left-handed girls to right-handed girls, then it's going to be 8 to 20. Okay, can we cancel that down at all? So common factors of 8 are, well, factors of 8 are 1, 2, 4, and 8. Factors of 20 are 1, 2, 4, and 5, and 20. So I think we can divide both of those numbers by 4, can't we? So dividing by 4, I should get a ratio of 2 to 5 in its lowest form. Part B said, what percentage of the boys are left-handed? What percentage of the boys are left-handed? Okay, well, altogether, we've got 3 plus 12, we've got 15 boys, and 3 of them are left-handed. So as a fraction, it's going to be 3/15, isn't it? So 3/15 of the boys are left-handed. Now I can divide top and bottom by 3, can't I, to simplify that fraction down a bit? So that's the same thing as 1/5. But actually I want to write this as a percentage, and a percentage then is a fraction over 100. So if I can take my 5 and multiply it by 20, I'm going to get 100. So let's do the same thing to the top. 1 times 20 is 20, 5 times 20 is 100, and 20 over 100 is the same thing as 20%. So 20% is my answer. Question 18 says, Liam says, if you divide any multiple of 10 by 2, the answer always ends in 5. Is he correct? Write down a calculation to support your answer. Okay, well, it's very easy to show that someone isn't correct as long as you can find one answer that says it's not correct. Now, so if you take, for instance, 20, which is a multiple of 10, and divide it by 2, you're going to get 10. And 10 does not end in 5. So, is he correct? Liam is not correct. Question 19. Translate the triangle so that the point A moves to the point B. Okay, so my point A is here, and it's moved to this point here. How far has it gone? It's gone 1, 2, 3 points down, or 3 squares down, and 3 squares along. Okay, now in order to translate this shape, then we've got to do the same thing with each of the other points. So taking this point down here, the bottom left-hand corner, 1, 2, 3 down, 1, 2, 3 across. That means that point ends up going there. And taking this corner here and going 1, 2, 3 points down, and 1, 2, 3 across goes to here. Okay, so just tidy it up a little bit. Get rid of those. So you can see my 3 points end up like that. Just join them together. Okay, done. Part B says rotate the triangle 90 degrees clockwise so that the point C moves to point D. 90 degrees clockwise so the point C moves to the point D. Okay. Now, probably, if you're doing this in an exam, the easiest thing to do would be to trace the triangle and then just try and stab the paper where you think that the center of rotation is, and try and turn it and see if it does line up. If you do that a few times, you should work out that the center of rotation is here. And then if you rotate your shape around that point, you'll end up with your triangle with corners here and here. Joining those together, I'm going to get that triangle. Okay. Question 20. Here is a formula. V equals a half of x squared h. Work out the value of v when x is 11 and h is 6. Okay, so we're going to sub those two values in. So v then is going to be a half of x squared, well x is 11, so that's 11 squared times h, which is 6. Okay, now I tend to sub in brackets like that. Helps me just keep track of what's going where. Right, now I've got different operations to do here. I've got a half, which is the same thing as dividing by 2. I've got a square, and I've got to multiply by 6. Now luckily I know BIDMAS, which tells me the order I have to do things. And I, for indices, comes before addition, division and multiplication. So the first thing you need to do then is the squaring. So 11 squared, 11 times 11, that is 121. So basically I've got a half times 121 times 6. Okay? Right, so now I've got a divide by 2 and a times by 6 to take care of. And actually division and multiplication have the same weighting. But it tends to be easier to divide by, do the division first. So for instance, I could divide that 2 into the 6 and leave myself with just 3 there, which will then make the multiplication a bit easier. So 121 times 3 is 363. So that's my answer, 363. Question 21. Diaries are sold in boxes of 12, pencils in boxes of 10, and rulers in boxes of 6. A teacher wants to buy the same number of diaries, pencils, and rulers. Work out the smallest number of boxes of each of them, of each item he could buy. Okay. So this really is a question on lowest common multiples, LCMs, isn't it? Okay, so we want to find the lowest common multiple of these 3 numbers. So let's start with the 12 and work out the first few multiples of 12. First few multiples of 12 are 12, 24, 36, 48, 60. Okay, let's just stop there and then try doing the first few multiples of 10. 10, 20, 30, 40, 50, 60. Oh, we've got one that matches there. Look, I wonder if we can make 60 out of 6. Well, I think we can. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. So there we go, 60 on all of them. So we could have 60 of each. 60 of each. Okay? So if we wanted 60 diaries and they come in box of 12, we're going to need 1, 2, 3, 4, 5 boxes, aren't we? 5 boxes of diaries will give us 60 diaries. How many boxes of pencils? I'm going to need 1, 2, 3, 4, 5, 6 of those. So 6 boxes of pencils. And how many rulers? Well, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those. So I need 10 boxes of rulers. Which fraction is closer to a half, 2/5 or 5/8? Now, whenever we're comparing fractions, the easiest thing to do, rewrite each fraction with a common denominator. So we're looking for a common denominator from 5, 8, and 2. So all 3 of those numbers go into 40. So I'm going to change them all into fractions over 40. So 2/5 is the same thing as, well, 5 goes into 40 8 times, so that's going to be 16/40. 5/8 is going to be the equivalent to 25/40, and we're comparing it to a half, which is 20/40. So the difference between 16/40 and 20/40 is 4, and the distance between 25/40 and 20/40 is 5. So I would say that 2/5 is the closest. Question 23. The scatter graph shows the number of driving lessons and the number of tests needed to pass by 10 people. Okay, what proportion of the 10 people passed on their first test? Well, the number of tests is down the side here, and if it's their first test, then it's got to be a number of tests needed to pass is equal to 1. And you can see that we've got 1, 2, 3 little x's on that line. So 3 people passed on their first test out of a total of 10 people. So what proportion of the people passed on their first test? It's going to be 3 out of 10, or 3/10. So you can see from here that as the number of driving lessons is increasing up the scale, so is the number of tests. So we clearly have strong positive correlation here. Now, in the questions, we're going to be going on to ask about that. So I can already say that correlation is strong positive. And then the next part of the question says, use a line of best fit to estimate the number of tests needed to pass by a person who has 50 lessons. So we're going to need to come back and put a line of best fit on this graph. So using your ruler, you want to place it in such a way as it passes through the points. You need to try and get the same sort of number on both sides of the line. Okay, looks about right to me. It's not a precise, exact science. You do get a bit of leeway either side. I think that looks about right. Okay, once I've got that on, I need to read up to the line of best fit from 50 and across. So again, putting the ruler on my graph at 50. So I'm going to need to read up to the graph at 50 and then along. Like so. And then this value here is my answer. So on this scale, it's about the 3.8 tests. So on average, it takes about 3.8 tests for a person who has 50 lessons. Mira says, I can use the trend to predict the number of driving tests needed to pass for any number of driving lessons. And we need to comment on the accuracy of this statement. So if we come back and look at the graph, you can see that we've got data for students having between 30 and 65 tests. And within that range, we clearly have strong positive correlation. What we don't have is any evidence or any data either side of that. So we've got no data for these low numbers here, and we've got no data for anything beyond 65 lessons. So whilst the data clearly shows strong positive correlation between 30 and 65, we've got no evidence that it does either side of that range. So I'm going to write here that estimates will only be accurate within the range of the data. Reliable, sorry. Between the range of the data, which we said was 30 to 65 lessons. Okay, on the diagram below, we're asked to shade an area that's represented by the expression AD plus CD. Now, some of the measurements are missing, but we can see because from here to here is A, then this is also going to be A here. And because from here to here is D, this is also going to be D here. So AD is going to be this central rectangle along here, so that's AD, and then CD can be either one of the smaller ones at the end. I'm going to pick that one there is CD, so between them that is the area AD plus CD. Well, the next diagram, we need to show the area represented by D times A plus 2C. Now, A plus 2C is, well, here's C, and here's C as well, and in between is A. So from here through to here is A plus 2C, and then we already know that that's D down there, so A plus 2C times D is all of this central part here. The final part of the question asks for an expression for the whole area of the shape. So this part here is A times B. This part here is CD. We've got another CD over here. In the center we had AD, and then we've got another AB down here. So altogether we've got two ABs, we've got two CDs, and we've got an AD. Concerns itself with this distance time graph. Now this is showing a race between three boys, Alan, Ben and Carl, over 1,000 meters. So we've got the time along the bottom and we've got the distance along the side. Okay, so normally who wins the race is the person who gets to the finish line first. So we should be looking at which of these three boys gets to the 1,000-meter mark before the others. So the 1,000-meter mark is here, this line. So I'll quickly draw that on. This is the finish line here. So you can see that Ben reaches it here, and then Alan and Carl reach it at the same time here. So the person who gets there first is Ben. He gets there at this point here at 4.5 minutes. So who won the race? Ben. So Ben won the race. Why? Because Ben finished after 4.5 minutes and Alan and Carl finished after 5 minutes. Okay, now the next part of the question asks us to describe the race, and it's worth 4 marks, so we need to come up with at least 4 statements about the graph. So we can read this graph from left to right, so you can see that as we start off that Alan starts off the fastest, so Alan is in the lead, then Ben is second and Carl is third for the first part of the race. At this point, at 2.5 minutes, Ben slows down. At 3 minutes, Alan stops for a while and then starts again soon after at a slower pace. At 3.5 minutes, Ben speeds up and then overtakes Alan. Carl speeds up at 4 minutes, but it's not enough to overtake anybody, but he does finish the race at the same time as Alan. So, writing all that down in the question paper, at the start of the race, Alan is fastest. After 2.5 minutes, Ben slows down. After 3 minutes, Alan stops. After 3.25 minutes, Alan starts again but slower than before. After 3.5 minutes, Ben speeds up. After 4 minutes, Carl speeds up. After 4.25 minutes, Ben overtakes Alan. After 4.5 minutes, Ben finishes. And after 5 minutes, Alan and Carl finish. So you can see I've written all those down just in chronological order, making a note of any changes along the way. Question 26. 2 straight lines are shown. A is the midpoint of OB and B is the midpoint of TS. work out the coordinates of t. So we're told that A is the midpoint of OB. Here's OB. And if A is the midpoint, look, O is the point 0, 0, isn't it, down here? Okay, now to go from O to A, we go along 7 and up 6. We know that because that's the coordinates, isn't it? 7, 6. And if we did the same thing again, so if we went along another 7 and another 6, we're going to get up to point B. So 7 add 7 is 14, 6 add 6 is 12. So B must have coordinates 14, 12. Okay? Now let's do something similar from B to T. Let's first look at how far it is from S to B. So looking at their x coordinates, this one is 25 and this one is 14. That has a difference of 11, doesn't it? So that distance there is 11. Their y coordinates, that's 4 and that's 12. That has a difference of 8. So that distance there is 8. So to go from B to T, we're going to have to go up 8 and we're going to have to go along another 11. Okay, so let's think about what we have to do with the coordinates then. So if I'm at B, which is 14, 12, and I go up 8, that's going to take me to 14, 20. 14, 20. And if I go left 11, I'm going to go from 14 down to 3, aren't I? So that's going to be 320. So T has coordinates 320. 320. Question 27. 3 straight lines are shown. Work out the value of x. Okay, well, they aren't just any old 3 straight lines, are they? We've got 2 lines here that have got arrows on them, which means that these are parallel lines, and we've got a line crossing them. And whenever we've got that situation going on, it forms various angles, and there are relationships between various angles that are formed. Firstly, if you have a think about that angle there, it is vertically opposite this one, which means that those two are equal. So that one must also be 2x plus 15. And similarly, this angle and this, so that one and that one are equal, but also that one and that one must be equal because they are what we call corresponding angles. So in other words, 2x plus 15, that angle up there must be the same angle as 3x minus 38. Now they might look different because they're written algebraically using different expressions. But if they're the same angle, then these two algebraic expressions must actually be equal. So if we equate them like that, we form an equation in x that we can then go on to solve. Firstly, we've got x's on both sides. So let's simplify it a little bit by subtracting 2x from both sides. So if I take 2x from that side, they'll disappear. And if I take 2x from the other side, it's going to leave me with 15 is equal to x minus 38. Okay, now all I need to do is add 38 to both sides. You'll see that minus 38 plus 38 are going to cancel each other out, leaving you with x on the right, and on the left 15 plus 38, that's 38, 48, 53, isn't it? That tells me that x is equal to 53. A fairly straightforward pair of simultaneous linear equations. I'm going to be using the elimination method to solve this. Let's label that one equation 1 and equation 2. So to eliminate x, I'm going to take equation 1 and I'm going to subtract 2 lots of equation 2. So let's just write equation 1 out again. 2x plus 3y is equal to 15.5. And then we're going to write equation 2 underneath, but we're going to double everything up. So we're going to get 2x plus 2y equals 12. Okay, now we can simply subtract one equation from the other. 2x take away 2x there's nothing. That's what we've done. We've managed to eliminate x. 3y take away 2y leaves us y. And 15.5 take away 12 leaves us 3.5. Okay, so we found y. Now we need to find x. To do that, we just need to substitute that back into one of our original equations. So substitute y equals 3.5 into, which one looks easier? I think I'm going to substitute into equation 2. So x is what we want to find, plus y, which is 3.5, is equal to 6. So rearranging that, I'm going to get x equals 6 minus 3.5, which is going to give me 2.5, my answer for x. Okay, now I am done, but it's always a good idea to check. So checking both of our answers by substituting into the other equation that we didn't use to find x. Just quickly, so so this is a check, isn't it? Check. 2 lots of x, 2 lots of 2.5 plus 3 lots of y, 3 lots of 3.5. Is that equal to 15.5? Okay, so 2 lots of 2.5 is 5. 3 lots of 3.5 is 10.5, and together, yes, they do make 15.5. So I'm quite happy that my answer is correct. Okay, so now I'm satisfied. I'm just going to write those two values in here. So x is 2.5 and y is 3.5. Question 29. In the diagram, the area of triangle ABD is 56. Work out the length of CD. Okay, in the diagram, triangle ABD. What is triangle ABD? Triangle ABD is ABD. It's this triangle here. Now we're told that the area of this one is 56 centimeters. Now we know that the area of a triangle is half its base times its height. So area of triangle is half base times height. So we know that the baseline of this triangle is 14, but we don't know the height. Let's call the height h. Okay, let's call it h. So then my area of my triangle, which I already know is 56, is going to be a half times my base, which is 14, times my value of h, which I'm actually trying to find. Okay? Right, what can we do with this then? So, half of 14, that's 7, isn't it? So actually what I've got here is 56 equals 7h, and then dividing both sides by 7. Sevens into 56 go 8 times. So that means that h is equal to 8. Okay, so now we know how tall this triangle is. It's 8. Now we want to find the length CD, which is this length here. Okay, now looking at the right triangle, that has got a length of 6 and a height of 8. So I want to know the hypotenuse of that right angle triangle. Now you can do this with Pythagoras theorem. I already know the answer because I know that 6 and 8 goes with 10. Okay, so I know already that it's 10 because I know what are the Pythagorean triples. Now these are very handy triples to know. So the first one is 3, 4, 5, and then any multiple of that is also a Pythagorean triple. So if you double each of those, you get 6, 8, 10. There's another one, 5, 12, 13. And knowing those means that if you have got a problem that involves Pythagoras theorem on the non-calculated paper, you can pretty much always work out what these are without even having to think about it. But let's assume you didn't remember the Pythagorean triple. You'd have to use that c squared was equal to a squared plus b squared, wouldn't you? So c squared equals a squared plus b squared, which in this case would be 6 squared and 8 squared. 6 squared is 36, 8 squared is 64. Adding them together, you're going to get c squared is 100, making c equal to 10. So my answer is 10 centimeters, as I already told you. Okay. Well, that's the end of the paper. Not too bad, I hope. Let me know how you did in the comments, and if you have any unanswered questions, why not ask them below. If you didn't do so well, time to hit the books a bit more and then come back and try another past paper in a few days. I'll be here to help you through that one too. And if you haven't already done so, why not subscribe so you can find me again for the next practice paper. Work hard, keep trying your best, and you will make progress. See you again next time.